Oh, it's frozen. We are on our fourth calculus rule. The derivative of a sum or difference. So up till now, we've just looked at single polynomials. And within those single polynomials, we looked at, well, what happens if there's a number in front? And we find that that number in front didn't make too much of a difference. We looked at what happens when you do the derivative of a constant. Anyone remember what the derivative of a constant is? 0. Excellent. And now we're going to look at, well, what happens when you're adding a bunch of these things together? And it's quite simple. If you're adding one or more functions that you already know the derivative of, you can take the derivative of each one separately. So that's what it's saying here. Here are two functions that you're adding together. If you want to do the derivative of those, you can just do the derivative of each thing separately. So in our first example, we end up having 5 different things. And so you can take the derivative of each one separately. What's the derivative of 3x to the 5? Well, the 5 would come out in front. You get 3 times 5 would be 15, x to the 4. What's the derivative of 2x to the 4? 4 would come out in front, making 8, and you would get 8x cubed. So remember the pattern where our exponent comes out in front, multiplies that number, and you subtract 1 from the exponent? That follows through with each of these. So the 2 would come out in front, hit the -7, you get -14. What's the derivative of just x? 1. And then the last one will be a -5. That'll be a 0. So we do the derivative of each one separately, and we get our final answer. Now this one was the most straightforward because we didn't have to take any square roots and change them to rational exponents. But we do have to do that in the second one and the third one as well. So I'm going to give you a head start on the second and the third one, and if you get those done early, you can try the fourth one. So for part B, a first step is rewriting this in a form where we can do the derivative. And the form that we can do the derivative is if you have x to a power. So the square root becomes a half. The x cubed on the bottom becomes an x to the -3. Then you can apply your laws for finding the derivative. The number comes out in front, subtract 1 from the exponent. Have to be a little bit careful with the negatives because you might have been tempted to write -2 when you subtracted 1 from the exponent. But remember that -3 minus 1 is -4. So this would be fine to write your answer this way. If you wanted to, those negative exponents could go down to the bottom. The 1/2 could be written as a square root. So it's good to be able to say, how can I manipulate this? What are different ways that I could write it? But both of those would be fine. And normally we would probably leave it as the top one if we were just finding the derivative. But if you were asked to plug in x equals 4, it's probably easier to evaluate if you had a square root rather than an x to a half. Everybody have a chance to finish part C? As a first step, change all of those things into a form where you can do the derivative. And once they are in a form that you can do the derivative, bring that number in front and subtract 1 from the exponent to each one. If you think back to our first derivative notes, this would have been like how many examples in one? 1, 2, 3, 4, 5, 6 examples all put together in one equation. And if you wanted to rewrite this in other forms, this is what it could look like. So this one is two binomials multiplied together. It currently is not in an adding or subtracting. It's multiplying. So we might think, well, maybe there's a rule for multiplying, but we haven't learned it yet. But we might think, maybe I can just do the derivative of the first one multiplied by the derivative of the second one. Maybe that'll work. But what we could do with this one is we could multiply it out. We could distribute, simplify our like terms, and we'll get 2x squared minus 4x minus 6. And by multiplying it out, now it's in a form that looks like things we've done before, so we can take the derivative of each thing separately. And the derivative of this one is 4x minus 4. So if your gut feeling was to just do the derivative of each one and multiply those together, you could check, did it actually work, or is it different?